Good day. Welcome to the GSWA Webinar Series. My name is Leon Normore and I'm a member of the Energy Geoscience branch of the Geological Survey of Western Australia. Today's presentation will discuss the Waukarlycarly 1 deep stratigraphic drilling program completed in December of last year and the ongoing post-well data acquisition. Waukarlycarly 1 was drilled in the southwest Canning Basin to a total depth of 2,680.5 meters as a joint project between Geoscience Australia and the GSWA. Funding was primarily from GA's Exploring for the Future program, with assistance from GSWA's Exploration Incentive Scheme. This presentation will briefly provide a summary of the Canning Basin and follow up with the two main stages of this project, the Kidson Sub-basin seismic survey and the stratigraphic drilling. I will quickly run through the details of the drilling program and the stratigraphy of Waukarlycarly 1 and then get straight into a preliminary depositional model. I'll then cover some of the preliminary results and finish up with the ongoing analysis and the upcoming publications. The Canning Basin occupies a very large part of the state and has over a century of petroleum exploration. There are a number of petroleum discoveries through a series of active petroleum systems, but there are a little over 300 petroleum exploration wells and less than 3,000 lines of 2D seismic onshore. Here's the location of the Kidson Sub-basin seismic line and the Waukarlycarly stratigraphic drill holes shown here. A major collaborative project was initiated in 2018 between GA and GSWA, focused on the southern half of the Canning Basin. Stage 1 was an onshore record 872 kilometer deep seismic line from the WA-NT border across the Canning Basin and up onto the Pilbara Craton. The main aims were deep imaging of Phanerozoic and Proterozoic basins, basement structure underneath, including the West Arunta and Patterson origins, and the Pilbara Craton, as well as the nature of their boundaries. The stratigraphic drilling was phase 2 of the Southern Canning program, and there were 4 core objectives of this study: to provide continuous core through the Canning Basin section, to provide a full suite of wireline logs, a vertical seismic profile to correlate stratigraphy across the Kidson Sub-basin seismic line, and to intersect 100 meters of pre-canning basement, and all 4 objectives were successfully accomplished for this project. Here's an aerial shot of the Waukarlycarly drill site. So we're on the edge of the Great Sandy Desert in the Interdune area in the center of the Waukarlycarly embayment. And this location was off any existing structure identified in the seismic. It's on a previously cleared site that had existing water bores sunk during the road construction. So Waukarlycarly 1 was spud on September 1st, 2019 and took 3 months to reach total depth. DDH1's rig ERO1 can be seen here in the center, and we have the Turkey's Nest or water supply off to the southwest. The camp accommodations was over to the east, and that was for 30 people. And the main offices were located on the north side of the drill rig. And there was an existing sump and water bores to the northwest. Here's a stratigraphic column of Waukarlycarly 1 and also the various casing points. So we have 95 meters of Yanina Basin at the base, and this is the deepest unit with gray weakly metamorphosed dolomite, which grades into a weathered red calcareous siltstone. This is separated from the overlying Canning Basin by a major unconformity and an unknown sandstone interval that is possibly the oldest sedimentary rocks that have been cored in the Canning Basin. This is overlain by sandstones of the lower Nambeat Formation, and this is conformably overlain by a thick mudstone interval of the upper Nambeat Formation. We have another unidentified sandstone interval conformably overlying the Nambeat, and then we have a major unconformity and deposition of the Carbo-Permian Grant Group, diamictites and sandstones. And the Grant Group is equivalent to the Patterson Formation, and it continues up to 96 meters where it's overlain by clays and mudstones from recent Playa Lake system. Now we'll have a look at the preliminary depositional model. This really builds on figures from the acoustic televiewer log interpretation report completed by Andy Wilson and Lena Thrain of ImageStrat. I'll get to details of this great report later, but Andy drafted 11 excellent block diagrams for the depositional environment for the upper part of Waukarlycarly 1. The ATV log was completed by Wireline Services Group for the upper 3 wireline suites, so it only reaches 1600 meters depth. Andy and Lena's synthesis figures were modified, and the depositional environments were extended both above and below to recreate a complete model for the entire Waukarlycarly 1 stratigraphic drill hole over geological time. So, here we start in a Neoproterozoic deep marine setting with the deposition of deep water carbonate muds. This is followed by a period of dolomitization. And then there's a significant period of compression and uplift, folding the Canning Basin and exposing the dolomites at surface. Then there's a long period of weathering from the Cryogenian to possibly late Cambrian over a period of 350 million years. This allows enough time for the formation of a thick regolith profile. And sometime in the late Cambrian or early Ordovician, there's an extensional event which marks the beginning of the Canning Basin. Immediately above the Canning Basin basal unconformity is the deposition of immature sands, possibly alluvial fans off the edge of a failed rift margin, interspersed with ash beds from nearby volcanoes. This transitions into a fluvial system, followed by a relative sea level rise and deposition of shallow marine environment for the lower Nambeat. Relative sea level continues to increase with the deposition of offshore mudstones of the upper Nambeat Formation. A shallowing event provides a subtidal environment in the top part of the upper Nambeat, before going back into deep marine muds. Relative sea level drops again to the offshore transition zone. And then we move into the lower shore face with the deposition of sands. Sea level drop moves into a foreshore depositional environment. Then there's a depositional hiatus from possibly the mid-Ordovician into the Carboniferous. There was likely uplift and erosion prior to the Grant Group glaciation, creating an angular unconformity. Glacial retreat deposited crossbedded conglomerates and subaqueous outwash fans. Distal glaciation deposited muddy diamictites with dropstones. This was followed by another glacial advance towards the north, producing soft sediment deformation structures. Final glacial retreat occurs in the top of the lower Grant Group, followed by another glacial retreat in the upper Grant. Final distal glaciation occurs, followed by another unconformity and possible erosion of Mesozoic sedimentary rocks. We have recent Playa Lake system deposits in the uppermost section of mudstone and clay. Here we show the dry phase, followed by the wet Playa Lake phase with ephemeral rivers flowing to the south. And finally, the most recent migration of dunes to reveal current day conditions on the edge of the Great Sandy Desert. Now we'll have a look at the prognosis versus the actual. Here we have a map of the drill hole location, along with the prognosis of the original well proposal versus the actual stratigraphy known thus far. We chose this area because there were no previous deep drill holes in this part of the Canning Basin, and this image really tells us that we chose a good location to fill the gap in our geological knowledge. The Permian section was much thicker than originally thought, and we're possibly missing a large part of the lower Ordovician to Devonian section. There is an absence of carbonates throughout the Waukarlycarly embayment and a much thicker Nambeat formation. We also have an unknown sandstone interval above the Nambeat and an unknown sandstone below the Nambeat. And this could be some of the oldest sedimentary rocks encountered in the Canning Basin, and we may be approaching the Cambrian. I'll have a quick look at the seismic interpretation. Our seismic pics caused considerable grief during drilling, as demonstrated by our discrepancies in the well prognosis. Alex Zan has spent a lot of time working on the seismic interpretation of the Kidson seismic line and the Waukarlycarly 1 vertical seismic profile to determine why the pics were off. One of the main issues that has potentially caused the discrepancies in formation pics is the out-of-plane effect. And this is due to the sloping nature of the Waukarlycarly embayment. It deepens to the north, and this may be causing an out-of-plane effect, indicating a shorter reflection distance than actual and causing the shorter pics. Another problem that this slide indicates is the unusually high sonic velocities in Waukarlycarly 1. Closer to surface, we have in the 3,000 to 3,500 meter per second range, compared to Kidson 1, which has 2,300 to 2,500 meter per second range for the same depths. So this suggests that the Waukarlycarly embayment was buried quite deeply and has since been uplifted to its present location, preserving a deeper signature in the sonic velocities. So this velocity trend is also more steeply dipping in the Waukarlycarly embayment than other wells in the southern Canning Basin. Now we'll have a look at some preliminary results. The basic data well completion report was published in June of this year as GSWA Report 206, and this includes the well summary, formation evaluation, drilling and completion data, and a wide array of appendices including daily drilling reports, geological reports, mud log, composite log, dry, wet, UV, and high logger photos, high logger report for cuttings, high logger report for the core, cement bond logs, wireline logs for each hole section, and a vertical seismic profile. This is a listing of all the currently completed datasets from Waukarlycarly 1. The Western Australian Petroleum and Geothermal Information Management System, WAPIMS, is the source of all information available on the Waukarlycarly 1 stratigraphic drill hole. This is a mix of GA and GSWA reports, and there's not enough time to discuss everything, but I encourage anybody who's interested to download these reports from WAPIMS for a closer look. Now we'll have a look at some of the data sets that are already in. We've had a palynology review from 7 samples in the grant group, and this indicates 3 spore pollen zones. The upper to lower grant group contact is between 580 to 650 meters, and this marks the transition from the uppermost Carboniferous to the lowermost Permian. Diane Edwards and her colleagues at GA are working on a detailed organic geochemistry study. The total organic carbon results were disappointing for the upper Nambeat formation. In other wells, such as Olympic 1 on the Broome platform, TOC values are up to 3.3%. However, the results from Waukarlycarly 1 are less than 0.5% TOC in 201 samples, with the exception of 1 anomalous sample in the grant group at 4.88% TOC. There was also fluid inclusion studies. The grant group displays weak, dry gas responses. The unknown sandstone number 1 shows mostly dry gas response with a single wet gas response. A number of petroleum peaks in the lowermost Nambeat, and the highest methane and liquid hydrocarbon responses recorded at the very base of the Canning from 2550 to 2580. And there's also helium elevated just above the basement. Here's an example of the rare petroleum inclusions identified in the thin sections. This example had white fluorescence indicating upper moderate gravity petroleum inclusions. "42 samples were selected for organic petrology studies. Reflectance of graptolites were used to calculate vitrinite reflectance equivalents. Thermal maturity analysis indicates oil window from 610 meters to 2,000 meters, with gas window from 2,000 to 2,450 meters. Mike Walker completed a petrophysical evaluation using the Wireline logs, along with selected core gamma intervals, permeability and porosity data, and petrography. Because the well was fully cored from 580 to TD, the core depths were taken as the primary depth reference, and the Wireline logs adjusted accordingly. The upper section, the Wireline depths agreed well with the core depths. However, deeper in the section, there were mismatches, and cable stretch may have been an issue. Reservoir quality and water salinity were determined throughout the cored interval, and 4 reservoir sections were identified. The unknown sandstone number 1 reservoir section was the best reservoir section. Contained over 500 meters of net porous reservoir with an average porosity of 16.5%. This also used a 10% porosity cutoff and 50% V shale cutoff. Interesting thing about this reservoir is the water salinity decreases with increasing depth, and there's a significant change at 1070 meters, which has also been picked up in the acoustic televier interpretation as a change in paleodip. One sample was analyzed for seal capacity. This sample is from 725 meters in the lower grant group interval. The SEM indicates a poorly sorted quartz, K feldspar, plagioclase, silt-sized grains surrounded by a finer grain matrix of muscovite and chlorite. The mercury injection results indicate a very tight sample with a conservative capillary pressure estimate ranging up to 8,500 psi. This equates to a potential CO2 column height of 772 meters. Additional sampling is planned in the lower grant group diamictite as well as the upper Nambeat mudstone interval. Here we are back to ImageStrat's very comprehensive structural and sedimentological analysis of the acoustic televier logs. This report used the borehole image logs to investigate geological structures, facies and facies associations, and in situ stress. The ATV log was acquired only in the upper 3 Wireline suites by Wireline Services Group from 214 meters to 1,598 meters. And this logged section was subdivided into 3 structural zones based on the interpretation of dipped azimuth walkout plots, the overall interpretation of bedding features, erosion surfaces, and fractures and faults. Borehole breakout gives the current compressional direction and fills a major gap in this data set in northwestern Australia. Breakout orientations indicate a maximum compressional stress of 84 to 264 degrees in the Waukarlycarly location. And this is approximately 20 to 45 degrees different from the nearest stress orientations known from the Canning Basin, which are northeast, southwest in the eastern Canning and also in the eastern Pilbara. And if you've seen Ruth Murdy's presentation a few weeks back on seismic, it corresponds to a flexure in the stress regime across northwestern Australia. Sediment dispersal analysis was carried out using the cross-bedding dips with the structural dip removed, and from 1332 to 1072 meters depth, the cross-bedding dips are overall towards the northeast, and from 1072 to 885, the cross-bedding dips change to the northwest. This change in paleocurrent also corresponds to the change in salinity that we mentioned previously, as identified in the petrophysical evaluation. And this could be a formation boundary or possibly represents a change in the regional tectonics. This really is a great report, which also identifies 26 image facies and 9 image facies associations, as well as a sedimentological synthesis with excellent illustrations of the depositional environment. I encourage you to download this report from WAPMS and have a look for yourself. We also have another excellent report completed by Chemostrat on behalf of GA. 9 distinct packages were identified throughout Waukarlycarly 1. 5 major chemical boundaries were interpreted at the top of packages 1, package 2, package 4, package 6, and between package 7 and 10. And these major boundaries may relate to either unconformities, hyadal surfaces, or sediment provenance changes. And the Ordovician sections in Waukarlycarly 1 have very different chemical signals in comparison to other wells in the Canning Basin, suggesting a different provenance or possibly an earlier sedimentary package. A tentative carbon isotope correlation to the biostratigraphically constrained sections of Argentina and South China suggests ages that range from latest Cambrian to middle Ordovician. We're currently extending this infill sampling program to better define the carbon isotope curve in Waukarlycarly 1 and possibly extend it deeper into the section. So we'll have a look at some ongoing analysis. So we have 2 unknown sandstone intervals, and we're still waiting on both geochronology and biostratigraphy to sort this out. But we do have some in-house geochronology on the ash beds and some detrital sandstones. We're also waiting on some CA Audi-Timms analysis. We have some sampling for conodonts and other microfossils, and we're still looking at source rock extracts as well. So here we have the Canning Basin geochronology, and this is a detrital sample from the basement. This reveals a typical Canning Basin detrital signature with standard Mesoproterozoic peaks of 1100, 1450, and 1800 million years, and a conservative maximum depositional age of 923 million years. So when we look at the Waukarlycarly and compare it to other samples in the Canning Basin, and we see that mesoprote fits quite well. Here's a little bit on the ash beds in the Canning Basin, and the 50 ash beds were identified and sampled on site, and these samples range from 10 centimeter thick gray friable porous ash beds to millimeter scale light green slippery ash beds as seen here. They're distributed throughout and they increase in content towards the base of the Canning. Now we'll look at some Canning Basin geochronology. The red samples are shrimp data from ashbed horizons, while the light blue data are detrital data from sandstone intervals. The dark blue samples are previous detrital samples from Ordovician intervals in other Canning Basin wells. So the in-house detrital and ashbed samples provide similar geochron signatures to the oldest formations in the Canning Basin, particularly the Nambeat Formation. Provenance includes components of the Patterson Origin, Musgrave, and Arunta provinces, and a minor component from the Yilgarn Craton. Additional samples are awaiting CAID-TIM analysis, but we've had very limited success thus far in finding fresh euhedral zircons. Amit Gori has completed a preliminary burial history plot using the thermal maturity data. This is ongoing work that will be updated once the stratigraphic ages of the unknown sandstones have been identified with geochronology and/or biostratigraphy. Deposition occurred possibly as early as the Cambrian, with rapid deposition during the early to middle Ordovician. There appears to be a potential hiatus until late Carboniferous, early Permian. This was followed by major glaciation, erosion, and then continued deposition possibly as late as the Cretaceous, as there's scattered Cretaceous outcrops in the northern part of the Waukarlycarly embayment. They're not present in Waukarlycarly 1 location, and this would again experience erosion prior to the deposition of recent muds and clays of the ancestral Lake Waukarlycarly. Finally, additional analysis and possible publications. We are currently doing a detailed core logging by Ian Kopp. We're also looking at doing additional seal capacity in the lower Grant and also in the upper Nambeat formation. We have sampled for conodonts and microfossils in the Ordovician section, looking at ashbed geochemistry, macrofossil assemblages, looking at doing a trace fossil interpretation, and the potential of other geochronology techniques. We're planning an extended abstract for APIA, and we're looking at publishing the interpretive well completion report in June of next year. We will follow that up with a digital core atlas. Thank you very much.